Okay, so today we're going to start learning about mole ratio conversions. Last week we've been working with identifying the mole ratio with a balanced chemical equation, and so here I have a balanced chemical equation. And I use the coefficients, remember, to determine the mole ratio. So before we start on this, I want you to look to your video guided practice handout. In the summary I wrote there, it says, chemical reactions give information about the amount of moles involved in the reaction. The coefficients are the relative amounts of moles of each reactant and product used or produced in the reaction. A mole ratio relates the proportions of moles of any two reactants or products. So if we look to our chemical reaction here, we can see that we have 2 moles of magnesium with 1 mole of oxygen gas to produce 2 moles of magnesium oxide. So we can use any of these to come up with a mole ratio. We can say 2 moles of magnesium to 1 mole of oxygen gas. That's 1 mole ratio. Or we can actually flip it. We can say that 1 mole of oxygen gas is to 2 moles of magnesium. So those are just examples of mole ratios. Now, before we start here, I want to go over our conversion process that we started last 6 weeks, okay? So remember, we're starting with our given. You always write your given, and then you implement your conversion factors. Now this is going to be where we're going to use our mole ratios. We're also going to be using our grams to mole conversion, and we'll get to that more later in the next examples. So remember, the next process is that you multiply the top and you multiply the bottom, and your last step is to divide to get your answer. So let's go ahead and work some examples so that we can get some practice here. So let's take a look at number 1 here. It says here, use the balanced chemical equations below to calculate how many moles of each product would be produced by complete conversion of 0.15 moles of the reactant indicated in boldface. So basically all it's saying is that we're starting with 0.15 moles of the reactant that's in bold. So for our case here, the reactant that's in bold is magnesium. So we're going to start with 0.15 moles of magnesium. And we want to know, according to this, how many moles of each product will be produced. This is what we're looking for. So in this case, our product is magnesium oxide. So we're going to convert from moles of magnesium to moles of magnesium oxide. Okay? So we start with writing what is given, which I already did here. And then we're going to use our conversions. So the first thing I want to do is I want to cancel out moles of magnesium. So the way that I do this is that I look to my balanced chemical reaction and I write my mole ratio. So how many moles of magnesium are there in my balanced reaction? Well, if I look here, I can see that there's 2 moles of magnesium in my balanced reaction. So I'm going to put that on the bottom because I want to cancel moles of magnesium. So by canceling that, I need to get something else. So I look to my balanced reaction yet again, and I identify, what am I looking for? Okay, I'm looking for how many moles of magnesium oxide were produced. So I put that on top, 2 moles of magnesium oxide. Okay, by doing this, my moles of magnesium cancel, and I'm left with moles of magnesium oxide, which is what I was looking for. That's what the question asked me to solve. Okay, so remember, all you do is multiply the top. So when I multiply 0.15 times 2, I'm going to get 0.30. And I divide that by the bottom, which is 2. So when I divide it, I'm going to get, again, 0.15 moles of magnesium oxide. The reason why this answer was the same as what I was given is because my mole ratio was a 2-to-2 ratio. Okay, so whenever your ratio is the same, your answer will be the same. And so just another reminder and something to point out here is that whenever we have a mole-to-mole conversion like we just did, it is only going to be one step. Okay, and that one step was our mole ratio. Our mole ratio allows us to convert from moles of a reactant to moles of a product. Okay? So let's go ahead and do number 2, which is another mole-to-mole. In this one, we have 4 moles of iron plus 3 moles of oxygen gas to produce 2 moles of iron oxide. So again, we are starting with 0.15 moles of the reactant indicated in bold-faced. So that one is going to be, our oxygen. So we're going to start with 0.15 moles of oxygen, because that's the one in our bold-face. So we want to know how many moles of the product will be produced. So our product here is our iron oxide. So we want to know how many moles are going to be produced if we use 0.15 moles of oxygen gas. So to start our conversion, we write down what is given, and we want to cancel moles of oxygen. So in order to do that, I have to look to my balanced reaction and see that I have 3 moles of oxygen gas. So I'm going to put that on the bottom because I want to cancel moles of oxygen gas. I want to know how many moles of the product is made, so I have to look to my mole ratio, or to my balanced equation to finish my mole ratio. So I'm going to write my 2 moles of iron oxide, Fe2O3. So my moles of oxygen gas cancel out. Remember, like cancels like. I am left with exactly what I was looking for, which is moles of iron oxide. Okay, so now all I do is multiply the top. So when I multiply the top, I'm going to get 0.30. And then I divide it by the bottom, which is 3. So my answer here is 0.10 moles of iron oxide that were produced. Okay, I want to point out something before we move on. Whatever you start with, okay, our given is what is used in the reaction. Our answer here is what is produced in the reaction. So remember I told you guys that chemical reactions are like recipes. Whatever you have in the reactants, those are your ingredients. Whatever you have in your product, those are the materials that are produced. So again, remember that whatever is given is what we're using in the reaction, and whatever our answer is what is produced in the reaction. So to interpret this one for us, if we have 0.15 moles of oxygen gas in this reaction, we will produce 0.10 moles of iron oxide. Okay? Now let's go to another one. It's a little bit more challenging. Okay, in problem set number 2, the instruction says, use the balanced chemical equations below to calculate how many grams of the bold-faced product will be produced by complete conversion of 1.25 moles of the reactant indicated in boldface. So to start off with, I just want to show you something. In the previous problems, we were just doing mole-to-mole conversions using the mole ratio. In this step, we're doing moles to grams conversions, so all of our problems are going to be 2 steps, okay? So we're going to work through those 2 steps following the same method that we did before, which is writing down what is given first. So in the reaction, it says we are using 1.25 moles of the reactant indicated in boldface. Well, in this case, the reactant in boldface is C2H5OH. So that is the reactant we're using here, C2H5OH. And it's very important that every time you write down all the information so that we can do our conversion correctly. So our first step is that we want to cancel moles of C2H5OH. So to cancel moles, remember we have to look to our balanced chemical reaction. And so we're going to identify that we have 2 moles of that reactant. So I'm going to put that on the bottom so we can cancel it. 2 moles of C2H5OH. And it says we're trying to figure out how many grams of the boldface product. In this case, our boldface product is H2O. So we're going to, in order to complete our mole ratio, we're going to use the moles of H2O. In this case, it's 6 moles of H2O. And with this first step, we have canceled moles of C2H5OH. And now we have moles of H2O. But we have to go back to the question. The question says calculate how many grams. So we cannot stop here. We have to keep going. So we want to cancel moles of H2O and get grams of H2O. So how do I do that? Well, for this, we have to think back to our mole conversions. We know how to do a mole to mass conversion. By that, we do 1 mole of H2O equals how many grams? So we have to look for the molar mass of water. And when we calculate it, 2 hydrogens plus 1 oxygen equals 18.015 grams. So by doing that, I canceled my moles of H2O, and now I'm left with grams of H2O, which is what it asked me to find. Okay? So my next step is to multiply everything on the top. So when I do that, I'm going to get 135.1125. And I multiply everything on the bottom. In this case, it's just 2 times 1. So we're going to divide it by 2. When I do that, I'm going to get 67.6 grams of H2O. Okay? Remember, whatever we're starting with, so in this case, we're starting with 125 moles of C2H5OH. This is what we used in our reaction, or this is what we used in our recipe. So using 1.25 moles, we were able to produce 67.6 grams of water. Okay? Remember, this is just a ratio or a relationship of what is used and what is produced in a reaction. Okay? For this one, we had to use 2 steps because we had to cancel moles and then cancel moles again and get grams. So let's go ahead and work to the next one and see if we can figure it out. Okay, so for this one, again, we're starting with our 1.25 moles, and our product, our reactant in bold is going to be our N2. Okay, so we're going to do 1.25 moles of N2, and we want to cancel our moles of N2 and get moles of our product. In this case, it's NO2. Okay. All right, I just realized that there's a typo on here, and that is this. We're not going to need this little 2 right here. So it's just 2 moles of NO. So our first step is to cancel moles of N2. So we have 1 mole of N2 in our reaction. And I want to get moles of my product. So I'm going to write my 2 moles of NO on top. This, again, this is my mole ratio. It's just telling me the relationship between different quantities of moles of reactant and product. By this first step, I cancel my moles of N2. Now I need to get my moles here and convert it into grams, because that's what the question is asking me, how many grams? Okay, so I have to do my next conversion, and I want to cancel moles. So I know that 1 mole of NO equals 30.006 grams. And that is just the molar mass. I add up 1 nitrogen plus 1 oxygen. So by doing this, my moles of NO cancel, leaving me with grams, which is what the question asked me to solve for. Okay, so now all I have to do now is my math calculation. So I multiply everything on the top, and when I do that, I'm going to get 75.015, and then I multiply everything on the bottom. It's just 1 times 1, so it's over 1. So my answer is 75.015 grams of NO. Okay. Again, I want to reiterate that whatever we start with, this is what we used in the reaction. Whatever we end with, this is what was produced in the reaction. Okay, so it's just like a recipe. If we're using a certain amount of something, we're going to produce a certain amount of something. Okay? All right, let's go do a couple more, and these are going to be a little bit more challenging, but let's see if we can get them. Okay, so for this one, the problem says, use the balanced chemical equations below to calculate how many grams of the boldface product would be produced by complete conversion of 2.3 grams of the reactant indicated in boldface. Well, for this particular problem, we only have 1 reactant because it's a decomposition reaction. So our reactant is hydrogen peroxide, or H2O2. And our boldface product in this case is oxygen. Okay, so I'm converting from grams of hydrogen peroxide to grams of oxygen. Okay, so I'm going to start by writing what is given in the problem. It says I'm starting with 2.3 grams of the reactant, so I'm going to go 2.3 grams of hydrogen peroxide, or H2O2. Now in my first step, I want to cancel these grams. So I'm going to use my mole to gram conversion. If I want to cancel grams, I have to put grams in the bottom. So I have to find the molar mass, which is 34.014 grams of H2O2 per 1 mole of H2O2. Okay, this is just a simple conversion of using molar mass. So my grams cancel. Now, in my next step, I want to cancel moles of H2O2, and I want to convert that to moles of O2, which is oxygen gas. So I'm going to use my mole ratio and my balanced chemical equation. And since I want to cancel moles of hydrogen peroxide, I'm going to put that on the bottom. 2 moles of hydrogen peroxide, or H2O2. And on top, I'm going to put whatever I want to get to, which in this case is moles of oxygen gas, and I only have 1 mole of oxygen gas in my reaction. So by doing this step, moles of hydrogen peroxide have been canceled. Now in my last step, The problem is asking me to calculate how many grams of the product there are. So for this one, I have to do a third step where I cancel out moles and get grams. So I'm going to use the mole to gram conversion for oxygen gas. So 1 mole of oxygen gas weighs 31.998 grams. And all I did was the mass of oxygen times 2. So that cancels out my moles of oxygen gas. And I have my molar mass here. So all I do is multiply everything on top. In this case, it's 2.3 times 1 times 1 times 31.998. And I'm going to get 73.5954. And I'm going to divide that by everything on the bottom. So 34.014 times 2 times 1 equals 68.028. So when I divide those two, I'm going to get 1.08 grams of oxygen gas. Again, remember, whatever we're starting with, this is what we used. Whatever the answer is what was produced in the reaction. So for this particular reaction, we used 2.3 grams of hydrogen peroxide. It decomposed and formed 1.08 grams of oxygen gas. That is what we just solved here. We figured out what we used and used that to calculate how much product was made. Now let's do one more and then we'll be done. Okay, so for this one we have the same procedure. We're still starting with 2.3 grams of the reactant. In this case, the reactant, we only have one reactant, and that is KClO3. Okay, so we're going to start with 2.3 grams of KClO3. And we want to get rid of grams because our ultimate goal is to calculate how many grams of the boldface product will be produced. In this case, our boldface product is KCl. Okay, so we're going to do our conversion here. So step 1 is to cancel grams of KClO3. So I'm going to do my grams to mole conversion using the molar mass. So the molar mass of KClO3 is 122.55 grams per 1 mole of KClO3. So my grams cancel. Now I need to use my mole ratio for my balanced reaction to go from moles of KClO3 to moles of KCl. So I want to cancel moles of KClO3, and in my reaction I have 2 moles of KClO3, and in my reaction I have 2 moles of KCl. So my mole ratio really is a 1-to-1 ratio, but I use it to cancel out KClO3. So now I'm dealing with KCl. In my last step, because the question is asking me for grams, I have to do another gram to mole conversion, but this time I'm canceling moles of KCl and getting the molar mass. So I know that 1 mole of KCl weighs 74.5513 grams. So now my moles are canceled, and I'm left with grams, which is exactly what the question asked me to find, which was grams. So now I set everything up correctly, so now it's just time to do the math. So in the calculator, you're going to do 2.3 times 1 times 2 times 74.5513, and you're going to get 342.94. And for the bottom, we're going to do 122.55 times 2 times 1, and that gives me 245.1. And then I'm going to divide those two to get my final answer. So I get 1.4 grams of KCl. Again, whatever we're starting with, this is what we used in the reaction. Whatever we're ending with, this is what was produced in the reaction. So if we think of it as a recipe, we could use a certain number of eggs for my cookies, and that will give me a certain amount of cookies. So a chemical reaction is just a comparison of how much we used and how much was produced. So I hope this was easy for you. If not, feel free to rewind and just go back to the areas you missed. Good luck.